Do you know if we take as many tennis balls as the number of molecules present in 2 gram of hydrogen gas, then the weight of those balls will be half the weight of our moon. So in this video we are going to understand the vastness of mole and also the percentage composition. The size of atom or molecules is so small that even in a small amount of any given substance, their number is very high. So we need unit that can easily handle such large numbers. So here we take the help of mole. Mole is a SI unit of amount of substance. And there are exactly 6.022 into 10 to the power 23 particles in 1 mole, which is a very large number. This constant is also known as Avogadro's number, and its unit is mole inverse. We can use Avogadro number to denote the number of any particle, whether it is an atom, molecule, ion, electrons, or any other particles. So on this basis we can say that there are 6.022 into 10 to the power 23 atoms in 1 mole of hydrogen, and 1 mole of water have the same number of molecules. And there are as many formula units in 1 mole of sodium chloride. Now we have learned that what is 1 mole. But what is the mass of 1 mole of substance? We call the mass of 1 mole of substance as molar mass. And if the molar mass of a substance is written in grams, then it is equal to the atomic mass, molecular mass, or formula mass of a given substance. Just their unit will be changed. For example, the molar mass of water is 18.02 gram per mole, which is equal to its molecular mass. Just the unit has been changed. The unit of molar mass is gram per mole. Percentage composition. Sometimes it becomes necessary for us to know the percentage of a particular element present in a molecule of a given compound. So it can be known from the molecular formula of that substance. As the molecular formula of water is H2O. Now suppose we have to find out the percentage of hydrogen present in the water molecule. We can calculate the percentage composition of hydrogen with the help of this formula. Total mass of hydrogen in water molecule divided by molecular mass of water into 100. So it will come around 11.18%. Similarly, we can also calculate the mass percentage of oxygen in water molecule. Empirical formula for molecular formula. From the empirical formula we get to know the ratio of constituent elements in any compound. This is the molecular formula of ethylene dichloride. It has 2 atoms of carbon, 4 atoms of hydrogen, and 2 atoms of chlorine. And their number of atoms are in the ratio of 2:4:2. So to get its empirical formula we have to convert the amount of all these elements into simple ratio. So the number of atoms of carbon, hydrogen and chlorine will have simple ratio of 1:2:1, which we can get by dividing this ratio by 2. So this would be the empirical formula of ethylene dichloride, CH2Cl. This has become a very simple thing. But in real life, to get the empirical formula of a compound, first we have to find the percentage composition of that compound. Then we find its empirical formula. And then we find its molecular formula. So the step-by-step process to find it is like this. Suppose the compound has 4.07% hydrogen, 24.27% carbon, and 71.65% chlorine, which we have found out after doing some experiment on that compound. Now if we take 100 gram of that compound, then 4.07 gram of hydrogen, 24.27 gram of carbon, and 71.65 gram chlorine will be present in it. Now if we divide the mass of these elements by their molar mass, then we can know their number of moles. Now to find their ratio in this compound, divide the number of moles of all the elements by the elements which has lowest number of mole. Here the element with the lowest number of mole is carbon and chlorine. So if we divide these 3 numbers by any one of the 2 numbers, then we will know their simple ratio. And we can write their empirical formula something like this. CH2Cl. If the molar mass of this compound is known to us, then we can also find the molecular formula of this compound. For this we have to first divide its molar mass by its empirical formula mass. The empirical formula mass of this compound will be equal to the sum of the masses of 1 carbon, 2 hydrogen and 1 chlorine atom. Now after dividing we will multiply the result by the empirical formula, which will give the molecular formula of this compound. So that's all for now. Hit the like button if you liked this video, and for more videos like this do subscribe this channel and don't forget to press the bell icon. Next we will learn about stoichiometry and stoichiometric calculations.